Hello everyone. Welcome to First Online University, a global platform for all your education and growth related needs. In this lecture, we are going to continue with the chapter Stoichiometry, and we will be talking about two very important concepts, that is scientific notation and significant figures. Before we begin, a piece of information for you. You can use the coupon codes Mission JEE or Mission NEET while you enroll at First Online University for Mission JEE or NEET. Let us now begin with scientific notation. Now, what is scientific notation? Scientific notations are used when one has to deal with extremely large or extremely small numbers, right? So when we are talking about, extremely large or extremely small numbers, we will have to deal with scientific notations because these numbers, see, suppose I have the value of something coming out to be 23.6789 and so on. So how do I actually put such a large value into, a value that is acceptable at all places? That is through scientific notation, and similar is the case when I have very small numbers also. So suppose I have say 0.00009876 and so on, like whatever. So then also I'll have to, for such a small valued number, I'll have to make use of scientific notation again. So this is where the term scientific notation comes into picture, and this is where it's going to be really important to understand the importance of scientific notation. So scientific notation has to be given by capital N into 10 raised to power small n. So I'm just speaking the capital and small to differentiate that the number that is coming before this 10 raised to power term is not the same as the power of 10. Where n is going to be a digit number that is going to vary between 1.000 and 9.999. And small n is the exponent that can be along with plus or minus sign. So when I say that speed of light is 300000000 meter per second. Is this how you're going to represent such a huge quantity? If someone is going to ask you, will you say it's like 3,000 lakhs or it's going to be like 30 crores? No, this is not how you tell the value. It's going to be represented in terms of scientific notation, and that is going to be 3 into 10 raised to power 8 meter per second. So this is the scientific notation for this particular value. So what are the uses of scientific notations? It is used in every mathematical conversions like addition, subtraction, multiplication, and division. So let us see how scientific notation is used in addition and subtraction concept. So it basically has two steps. First of all the numbers are going to be written in such a way that they will have the same exponent. And when we have made 10 raised to power, that is the value of the power of 10 has been made equal for all the values that have to be added, then whatever coefficients are there along with 10 raised to power term, that will be added or subtracted. So for instance, if I have to add these two terms, so the first thing that I have to keep in mind is the first point that I have to make the exponential part same. So either I'll make both of them 10 raised to power 4 or I will make both of them 10 raised to power 3. Now let us understand how I'm going to proceed with this. Now if I remove 110 from here, this will get converted into 10 raised to power 3, and the 10 that is left is going to be multiplied here, so it becomes 66.25. So 66.25 into 10 raised to power 3 plus 8.95 into 10 raised to power 3. So now it becomes easy to add 66.25 and 8.95, and 10 raised to power 3 remains as such. Or the other way around could be that when I shift this decimal to the left, how you have to learn or how you have to memorize this. So it's like when it goes to the left, one should be subtracted from the power. One should be subtracted, but it is not subtracted, it is added. So when it goes to the left, when the decimal goes to the left hand side, you will have an addition in the power. When it goes to the right hand side, you will have a subtraction in the power. So it's going to the left hand side, as you can see here. So it goes to the left hand side. It comes from here to here. So it is going to be added in the power. So now you simply have to add 6.25 and 0.895 and you get the answer as 7.545 into 10 to the power 4. Now, had you done it in the other way that I just told you, that was converting both into 10 to the power 3 terms, then you would have had 66.25 plus 8.95. The answer would have been 75.45. Again, you would have to convert it back into the scientific notation, that is decimal after one place. So you would again have to, move the decimal to the left hand side, adding one power. So you would have to, would have to done, you would have had to do it twice, which is not something that is preferable for saving time. So in order to save time, always prefer the conversion, which is going to make your work easier. That is where you can directly get the answer in the scientific notation. You do not have to move the decimal place again. Okay. So since we have to change both the values to the same exponent, this is how we proceed. Let us look at another example through subtraction. So subtraction of 2.5 into 10 raised to the power minus 2 and 0.48 into 10 raised to the power minus 2. Now, since 10 raised to the power minus 2 is the same, we do not have to change the exponents. We can simply subtract. 10 raised to the power minus 2 will remain as such, and we get the answer as 2.02 into 10 raised to the power minus 2. The next is multiplication and division. Now, these two operations are going to follow exactly the same rules which are there for exponential numbers. Okay, so if we look at this, that is 5.6 into 10 raised to the power 5 into 6.9 into 10 raised to the power 8. Now we know whenever the same base numbers are going to be multiplied, that is 10 raised to the power 5 into 10 raised to the power 8, since base is the same, the powers are going to get added and whatever coefficients are there, they are going to be multiplied. So 5.6 and 6.9 are going to be multiplied. 5 and 8 will be added in the exponent. So we get the answer as 38.64 into 10 raised to the power 13, which is not the scientific notation. The decimal has to be after 1 point. That is 1 unit place. So that's going to be 3.864 into 10 raised to the power 14. That's the answer. Now let us talk about, so this was the basic definition and examples of scientific notation. Now we will talk about significant figures. Let us have a look at significant figures now. Now, what are significant figures? They are basically those meaningful digits which are known with certainty. Okay. Only the meaningful digits that we know for sure are going to be the case. So in general, the experimental measurements that are done can be precise or accurate. Precise means it is going to be near about the value that is expected. Accurate is it's going to be exactly the value that we expect as an answer. So that's the difference between precise and accurate. These are two very, very important concepts that you will learn in mathematics also. Now, what is the importance of significant figures? The uncertainty in the experimental or calculated values are indicated by significant figures. For example, the animation of a practical room, right? So if you see, this first figure is accurate because it is exactly the same and it is also close to or nearby to what we expect. So that is accurate as well as precise. Now here, it is not accurate because it is not exactly where it is supposed to be near my arrow that I'm moving, but it is somewhere close to what we expect. So it is precise but not accurate, and this is neither precise nor accurate. For example, if the true value is say 2.00 gram, from these three, which is going to be accurate and precise? So measured by a student, he says it's 1.93 grams and 1.95 grams. The measured value by B student says it's 1.94 and 2.05 grams, and the measured value by C student is 2.01 and 1.99 grams. So if we see that for student C, the values are the closest that we expect it to be. So by student A, it is nowhere, even precise or accurate. The answer is student C, which is both accurate as well as precise. Why accurate? Because if he's performing the experiment twice, the value that he should get will be the average of these two, which is exactly equal to 2. But even if we do not take the average, we see the two other, results. That is separate results for experiment 1 that he has performed and separate result for experiment 2 that he has performed. He is precise. And if we take the average of the two, he is accurate. So the answer is student C. Now, what are the rules for determining the number of significant figures? How do we know the number of significant figures? The rules for determining the number of significant figures are all the non-zero digits, okay? All the digits that are not equal to 0 are going to be significant. For example, in 285 centimeter, there are 3 significant figures. The zeros that are preceding to the first non-zero are not significant, okay? So if I say 0.825 centimeter, 0 has no value. 825 centimeter is the answer. So 0.03 has one significant figure, okay? So preceding zeros have no value, so 3 is the only significant figure. Here 5 and 2 are two significant figures, right? So zeros between two non-zero digits, they are significant. If I say 303, so that is significant. Here 0 is going to be significant. 2.005 has 4 significant figures here because there is a 2. So had this been 0, we would have just had one significant figure. But now, since we have two zeros in between these two, so there are going to be 4 significant figures present here. So zeros at the end or right of a number are significant provided they are on the right side of the decimal point. For example, 0.200 has 3 significant figures. It is on the right hand side of the decimal, so it is going to be significant. So if a number ends in 0 that are not to the right of the decimal, the zeros may or may not be significant. So if I say 1500, that may have 2, 3 or 4 significant figures. This confusion can be significant by expressing the number in scientific notation. So when I represent it as 15 into 10 raised to the power 2, where n is the significant figures and whatever goes in the exponent is not the significant figure, so we say that there are just two significant figures. So whatever rules I've just spoken for significant figures are really, really important. Go back, revise them as many times as you can because one or two direct questions can be asked from this. Exponentials, remember, are not significant. Lastly, it may be emphasized that exact integral numbers such as 2 balls or 20 eggs, they have infinite significant figures and they can be represented using as many zeros after the decimal as possible. And we know that zeros after the decimal are going to be counted as significant figures. So they will have infinite significant figures. Now let us have a look at the addition and subtraction of significant figures. The addition and subtraction basically involves the result cannot have more digits to the right of the decimal point than there are in the original number, which has least number of digits to the right of the decimal point in it. Let us understand this through an example. So if I say 12.11, 18.0, 1.012, these all are to be added. When I add them, if you see 18.0 has only one digit after the decimal point. Therefore, the answer is 31.1. So when you are adding so many digits together, so many values together, the value that will have the least number of significant digits after the decimal is going to decide how you are going to report the answer in terms of significant numbers. Next is multiplication and division. So in these operations, the result must be reported with no more significant figures as there are in the measurement with the few significant figures. Again, let's understand this through an example. So 2.5 into 1.25 is 3.125. Again, 2.5 has just two significant figures and therefore the resultant should not have more than two significant figures. The same rule that we had applied for addition and subtraction. Now, what are the rules in rounding of the number? This was 3.125. 2 was less than 5, so we cannot write it as 3.2 as approximate. We will write it as 3.1. So how are we rounding off the numbers? The digit on the extreme right, that is the last digit of a number, has to be removed. If the rightmost digit to be removed is more than 5, then preceding number will be increased by 1. For example, if it's 1.386, I have to remove 6. Since it is greater than 5, so I'll add 1 to 8, that is 1.39. If the digit to be removed is less than 5, then we will round off by, basically when we are removing 5, we have to increase the rounded off to 6.2 only. It should be 6 point. Okay. So when we are removing 5, so it's like if it's like 6.34, simply 4 will be removed. We will have 6.3 as the answer. But if we are removing 5, subtract 1 from the previous digit. So it's 6.2 only. So if we have 4.334, it's going to be 4.33. And if the digit to be removed is 5, then the preceding number is not changed. Okay, so sorry. Okay, sorry. If it's 6.35, it will be rounded off to, okay, this rule we will see here. For this statement, we have this example. Okay, so if it's less than 5, that is 4 is being removed. So it will be 4.33. No changes will be made in the preceding digit. But if we have 5 that has to be removed, then if the preceding digit is an even number, it will not be changed. But if it is an odd number, then it will be changed. So since it is 6.35, we are removing 5. So 1 will be added because 3 is odd number. So 6.4 is the answer. Example 2. So if it's like, what is the sum of this kg and this kg? Find out the solution and then match the answer. So 2.368 kg plus 1.02 kg, the answer is this. Again, since we have to follow the least significant digit rule, it will be rounded off to two decimal places. That is, since 8 is being removed, which is greater than 5, so 1 will be added to the preceding digit and the answer will be 3.39 kgs. So this is all about scientific notation and significant digits. The rules for significant digits is very, very important. Write these down, write these rules down somewhere so that you do not forget them and you are able to use in the questions. You can subscribe to our YouTube channel for joining YouTube live classes for best NEET or JEE coaching. You can also download the First Online University mobile app for continuous learning through your smartphones. Keep learning with First Online University, a team of millions of learners and educators worldwide.